Hello students. Hello and welcome to this video on binomial theorems and multinomials. In this video, we will solve question number 241 to 250, and the link to download the PDFs will be in description, as well as at the end I will show you how you can download the updated copy of PDFs from the website or read the HTML format if you want. I will also show you my question answer website where you can come and ask questions or give answers. So without further ado, let's get started. Question 241 says that if mod of x less than 1, show that 1 plus x to the power minus 1 is equal to 1 plus x to the power minus 1 is equal to 1 minus x plus x square minus x cube and so on up to infinity. So following like question 240, 1 plus x to the power minus 1 is equal to 1 plus minus 1 upon 1 factorial x plus minus 1 times minus 1 minus 1 upon 2 factorial x square plus minus 1 times minus 1 minus 1 times minus 1 minus 2 upon 3 factorial x cubed and so on up to infinity, which is equal to 1 minus x plus x square minus x cubed and so on up to infinity. Then we have question 242, which says that if mod of x less than 1, show that 1 plus x to the power minus 2 is equal to 1 minus 2x plus 3x square minus 4x cubed and so on up to infinity. So similarly, if these are all the expansion of binomial theorem with negative indexes, 1 plus x to the power minus 2 is equal to 1 plus minus 2 upon 1 factorial x plus minus 2 times minus 2 minus 1 upon factorial 2 x square plus minus 2 times minus 2 minus 1 times minus 2 minus 4 upon 3 factorial x cube and so on, which is equal to 1 minus 2x plus 3x square minus 4x cube and so on. Question 243 says that if mod of x less than 1, show that 1 minus x to the power minus 3 is equal to 1 plus 3x plus 6x square plus 10x cube and so on up to infinity. So following similarly, we have 1 plus minus 3 upon 1 factorial minus x plus minus 3 times minus 3 minus 1 upon 2 factorial minus x square plus minus 3 minus 3 minus 1 minus 3 minus 2 upon 3 factorial minus x cube and so on up to infinity, which is equal to 1 plus 3x plus 6x square plus 10x cube and so on up to infinity. Question 244 says that if mod of x less than 1, show that 1 plus x to the power minus 3 is equal to 1 minus 3x plus x square minus 10x cube. So it is analogous to 243, just that power is now plus x instead of minus x. So we have got this series. So similar problem, just like previous one. Question 245 says that if mod of x less than 1, show that 1 plus x to the power minus 1 upon 5 is equal to 1 minus x upon 5 plus 3x square upon 25 minus 11x cube upon 125 and so on up to infinity. So the expansion is 1 plus minus 1 upon 5 times 1 factorial into x plus minus 1 upon 5 times minus 1 upon 5 minus 1 times 1 upon 2 factorial x square and so on, which is equal to 1 minus x upon 5 plus 3x square upon 25 minus 11x cube upon 125 and so on. Question 246 says that find the first 4 terms of 2x upon 3 minus 3 upon 2x to the power minus 3 by 2. So we expand this, we rewrite this as 3 upon 2x to the power 3 by 2 times 1 minus 9 upon 4x square to the power minus 3 by 2. This is equal to 2 upon 3 upon 2x to the power 3 by 2 times first term will be 1 and the second term will be minus 3 by 2 times minus 9 upon 4x square. The third term will be minus 3 by 2 times minus 3 by 2 minus 1 times 1 by 2 factorial minus 9 by 4x square whole square. And fourth term will be minus 3 upon 2 times minus 3 upon 2 minus 1 times minus 3 upon 2 minus 2 times 1 upon 3 factorial minus 9 upon 4x square to the power 3. And we finally see that the first 4 terms would be 3 upon 2x to the power 3 by 2 multiplied with 1 plus 3 upon 2 times 9 upon 4x square plus 3 times 5 upon 4 times 2 factorial times 81 upon 16x to the power 4 plus 3 times 5 times 7 upon 8 times 2 factorial times 729 by 64 x to the power 6. So that those will be the first four terms. Question 247 says that find the first three terms of 1 minus x upon 2 to the power minus 2. So first three terms would be 1 plus minus 2 upon 1 factorial times minus x upon 2 plus minus 2 minus 2 minus 1 upon 2 factorial times minus x upon 2 whole square. So first three terms will be 1 plus x plus 3 upon 4x square. Question 248 says that find the coefficient of x to the power 6 in 1 minus 2x to the power minus 5 by 2. So coefficient of x to the power 6 would be minus 5 upon 2 times minus 5 upon 2 minus 1 times minus 5 upon 2 minus 2 times minus 5 upon 2 minus 3 times minus 5 upon 2 minus 4 times 1 upon 5 factorial times minus 2 to the power 5, which will be equal to 15,015 upon 16. Question 249 says that find the r plus 1x term and its coefficient in 1 minus 2x to the power minus r. So rx term would t plus r plus 1x term would be minus 1 upon 2 times minus 1 upon 2 minus 1 times minus 1 upon 2 minus 2 and so on up to minus 1 upon 2 minus r plus 1 times 1 upon r factorial minus 2x to the power r factorial. And thus we have the term 1 into 3 into 5 and so on up to 2r minus 1 upon r factorial times h to the power r, and coefficient is 1 times 3 times 5 up to 2 to the power 2r minus 1 upon r factorial. Now we come to the last problem of this set. Show that 1 plus 2x plus 3x square plus 4x cube up to infinity to the power 3 upon 2 is equal to 1 plus 3x plus 6x square plus 10x cube up to infinity where mod x less than 1. So 1 plus 2x plus 3x square plus 4x cube up to infinity to the power 3 by 2 is equal to 1 minus x to the power minus 3. See, we have proven this 1 plus 2x plus 3x. We are not proven. So it would be 1 minus x to the power minus 2 actually. Okay. So 1 minus x to the power minus 2 to the power 3 upon 2 would be 1 minus x to the power 3. Now 1 minus x to the power 3 we have proven is equal to this. And that is how we have this series as well. With this we come to the end of question number 250. Now remember that we have 267 problems. Okay. So 17 more problems. So what we will do is we will split that into two parts. Or maybe what we can do is we can tackle some problem in this video. No, we will split this into two more videos. Next video will be 251 to 260 and finally 261 to 267. In that fashion we will do. Now to download the books, you can come to my website ashtavaka.org. Link 2, 3 and 4 are PDFs of algebra, trigonometry and coordinate geometry, and HTML format is also available for coordinate geometry. So this date you need to add in the downloaded PDF, and after 15 or 30 days you come and visit again to see if the PDF has changed. If the PDF has changed, you can download again and add the date again. About the HTML format of coordinate geometry, what you need to do is ideally you want Firefox browser because it uses MathML and Firefox has best MathML support. Although Safari and Chrome also support MathML. So if you don't want the PDF, you can read the HTML format online as well. To ask and answer questions, you click the link, H link, that is kundika.ashtavaka.org. Make a login here and use the tags of algebra, calculus, geometry, coordinate geometry, mathematics, probability, and trigonometry to ask or answer questions. If you need other tags, you can come ahead and ask for me in one of the questions and I will create those tags. So with this, we come to the end of this video and we will meet again tomorrow with 10 more problems on binomial theorems. Now if you see the table of contents, we have determinants and matrices remaining and then miscellaneous problems. And after that, this book will be finished and we will start with trigonometry. So it will take a while. It is not that immediately we are happening. It will probably take 3-4 months and then we can start trigonometry. So with this, I'll end this video here and we'll meet again tomorrow with 10 more problems on binomial theorems. So thanks a lot for watching the video. Have a great day ahead. Stay curious, keep learning, and most importantly, enjoy.